At 15 seconds, guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6.
Take a good look at what happens when a rocket launches. Billows of dust, smoke, and fire fill the air as the rocket blasts off at more than 40,000 kilometers per hour until it is nothing more than a dot in the sky. But before the rocket can even be tested, it goes through a grueling 4-mile journey that is perhaps more interesting than the launch itself. Every NASA rocket for the last 60 years has been moved by this $144 million transporter. It's the heaviest self-powered vehicle on Earth, large enough to fit a professional baseball infield and a key part of every NASA launch program, so much that if any part of it isn't right, the whole process gets halted immediately. But what is so important about this crawler, and what does it take to keep this 60-year-old technology moving? Picture this. The year is 1963 and the Cold War is at its peak, with both the US and Russia looking to take their frosty conflict to a whole new frontier: space. Both countries were racing to see which of them would produce the most innovative technology that would eventually lead in bringing the first humans to the moon. And while NASA eventually achieved their historic goal with the Saturn V, it wasn't the only massive technology that came out of the space race. To move their rockets from the assembly building to the launch pads, NASA had to develop a machine that wasn't just big enough to withstand the weight of the rockets, but stable enough to make sure that nothing gets damaged or spoiled during the journey to the launch pad. Remember, rockets are very expensive, and damaging any part of it even by mistake was not an option. But there was a problem. NASA hadn't developed any systems so advanced to make moving massive rockets possible, and there was nothing in existence at the time that was capable of carrying rockets of that size and weight. So what do you do when you have what seems to be an impossible obstacle in front of you? You flip the script entirely. NASA got in contact with the Marion Power Shovel Company, and together they began developing a machine that is a marvel in its own right. It was kind of like trying to build a massive tank, but for rockets. And this was a task that had many engineers scratching their heads, but the engineers soon realized that the solution to this problem already existed in Marion's factory. The company had a lot of experience manufacturing large mining equipment like the Bucharest Erie machine. So instead of starting from scratch, the engineers took a gamble and decided to use existing design concepts for steam shovels and modify it to suit what they were already looking for. And in 1966, NASA's vision came to life. The crawler is an awe-inspiring machine, 131 feet long and 113 feet wide. Its flat upper deck measures 90 square feet, about the same size as a baseball diamond. Only 2 of these crawlers exist, and they move on 4 double-tracked thread belts similar to those you'd find on a military tank. Each thread has 57 steel shoes that weigh about 2,100 pounds each, destroying all the river rock lining the path to the launch pad to dust. It is also powered by 2 2,750 horsepower diesel engines and a Marion-devised hydraulic system. While these machines would have been game changers for any other vehicle in terms of speed, for the NASA crawler that is just a drop in the bucket, as it still moves at a painstaking speed of 1 mile per hour. Can you think of anything else that's slow? And ever since it was first put to work in 1966, every NASA rocket has already put in over 3,500 miles in its storied history. Structurally, NASA has made sure that the crawler has stayed the same as it was when it first carried the Saturn V to the launch pad. The crawler was very ahead of its time, but this machine was specifically designed to carry the Saturn V to the launch pad, so there wasn't any real guarantee that it was going to last beyond its first few years of use. And the reason it has stayed working for this long is because of the team of engineers dedicated to making sure that this machine is at its best shape anytime it's wheeled out to the launch pad. The crawler is so massive and complex that at any given time there is a crew of 25 to 30 engineers constantly maintaining and watching its every move. There is the main driver and a backup driver. The drivers operate the crawler from either one of two driver cabs located at opposite ends of the machine. If there's any need to reverse the vehicle, the driver has to work to the opposite side to steer it from there. Then there are engineers in the engine room, another set of technicians in charge of the pump room, and technicians walking around the catwalk to keep an eye on every part of the hydraulic system. On the ground, there is another team of engineers walking all around the crawlers as it moves. Due to the crawler's size, it's very hard to keep it in a straight line. Also, it can only steer up to 6 degrees, and the driver has to constantly tweak the controls to make sure that the treads are moving straight at all times. The engineers on the ground also make the driver's job easier because they have a better vantage point of everything that could possibly go wrong when the vehicle is moving, and they are in constant communication with the driver to make sure the vehicle stays in line. But even though there is a team dedicated to each major part of the vehicle, every engineer is required to know just about everything regarding the machine and how to maintain its 70,000 individual parts. It takes an engineer anywhere from 1.5 to 2 years to learn every control and every detail that goes into making the crawler what it is. Engineers never fully shut down the crawler. Instead, it is put to sleep, and one of the engineer's tasks is to make sure that the engines always stay lukewarm so that the vehicle can start at optimal performance. Every time the crawler is brought out for a task, the team is responsible for making sure that billions of dollars worth of equipment make it to its destination in one piece. There is no room for any errors, so before anything is done, the crew inspects every inch of the crawler and the path to make sure there's nothing that can obstruct the crawler. With everything working perfectly, the team gets the all clear and the engine is started to get the task underway. While it moves, another vehicle filled with 30,000 gallons of water moves in front of the crawler and sprays the path with water. And this single step is an essential part of why the vehicle still works till this day. As the vehicle moves on the path, it pulverizes all the rock and stones in its way, creating a lot of dust. If the dust goes unchecked, it goes up to the motors and clogs them, making it difficult for the vehicle to move properly. By wetting the path, it keeps the dust in check and also changes the friction on the ground, making it easier to steer the vehicle. From prepping the crawler to moving the rocket to the launch pad, it takes about 10 hours for the team to fully complete the task. And when you are on the ground for such a long time, the job gets very monotonous. Sometimes the drivers have to rotate out every 3 hours to prevent fatigue and ensure that they remain alert at all times. Yet, even though there's better technology now and NASA can make something faster and smarter than the crawler, there are no signs of retiring the vehicle. Regardless of the challenges that come with maintaining and driving it, the team currently in charge of the crawler are eager to see it have a full circle moment. NASA currently has plans to return to the moon and, if possible, launch another rocket soon after on a successful mission to Mars. And since this was part of NASA's original lineup, the crew is determined to keep the crawler moving until it can make another historic return by carrying the launch vehicle that will support humanity's return to the moon and beyond. Is it ambitious? Yes. But if they have kept it going at the same performance for this long, there's nothing stopping them from making that happen. And what do you think of NASA's crawler transporter? Do you think it's possible to keep it going till we make the historic return back to the moon? Share your thoughts in the comments section below and don't forget to like and subscribe.